Well, hello everyone, and good morning to today's webinar on 500 VA Hipot Testing. My name is Syed Abidi, and I will be the presenter today. Also helping us today for question and answers is Dwayne Davis, our services manager, and Jim Kenzie, who's the host for today's webinar. Few things to note before we get into the material. We have a question and answer utility for you guys to ask us any questions concerning the material that's being presented. Any questions related to audio, visual, or any technical issues with the webinar, you can contact, those questions can be addressed to the host, Jim Kenzie, through the chat line. This webinar is also being recorded and should be available to view tomorrow on our website. And you can contact Jim Kenzie, who's the host, at jimk@asresearch.com if you would like a copy of this presentation. Okay, before we get into the real deal, just a quick outline of what we're going to be covering today. The topic is 500 VA Hipot Testing. We're going to be going over the Hipot test itself. We're going to be looking at some differences between AC and DC Hipot testing. Then we're going to look into the requirements of 500 VA testing and why is it necessary, where is it required, what is 500 VA testing, and then we're going to give you a few examples of 500 VA Hipot testers that Associated Research makes, and we're also going to show you a small video of a quick Hipot test using a basic resistor. So let's not waste any more time and get into the material. First of all, the dielectric withstand test, or high potential test, also known as Hipot test. What is this test? Well, the Hipot test is basically designed to stress the insulation of a product far beyond what it will encounter during normal use. Basically, Hipot test is an electrical safety test that is designed to stress the insulation of a device beyond what it will encounter during normal operation. Well, the logic behind this test is that if the insulation can withstand the application of a very high potential for a short period of time, it should be able to operate throughout its life cycle without posing a shock hazard to the user. So when running a Hipot test, high voltage is basically applied to the mains conductors, and the return point of the circuit is connected to the chassis or protective ground. The resulting current that flows through and on the surface of the insulation is known as leakage current. So next we're going to show you a quick video of a basic Hipot test. Wait till this video loads up. Okay, so basically what we're doing, what we were showing you here is the Associated Research Hipot 3 Model 3780, which is a 500 VA tester, and this is a TVB2 test verification box. So we're going to be doing, basically what's behind this is are a bunch of resistors. So what we're going to do is let me just play this video again because I know it's a short video. And so essentially right here we're looking at the Associated Research 500 VA tester. You can see it is set to at a test voltage of 1.24 kV and a high limit of 10 milliamps. Well, the high voltage lead on the right side is connected, and the return is also connected to the return on the TVB2 box. If you look here at the TVB2 box closely, you can see we're connected to a 2 meg ohm resistor. And once we hit the test button, high voltage is applied to this resistor, and the return is measured. So you can see that this is a pass at 1.24. If you use Ohm's law to calculate the leakage at 1.24 volts and 2 mega ohms, you should be getting 0.62 milliamps, and that's what the tester is basically showing us. So that's the example of a basic Hipot test, how to perform a Hipot test. Okay, so once again, basically running a Hipot test, what it does is it creates, essentially creates a capacitor, and measuring the leakage current flowing through the insulation, which in this case would be the dielectric material of the device that's being tested. Running an AC Hipot test basically means that there will be 3 current components in the Hipot circuit. Now, before we get into the AC Hipot test, let's just look at 500 VA. It basically refers to AC Hipot testing. We're going to get into AC and DC very soon, but it's good to know before we get into that 500 VA is basically referring to AC Hipot testing. So basically what we're doing is during an AC Hipot test, there will be 3 current components. One would be the real current, which is attributed to the resistive elements in the circuit. Then we'll have the reactive current, which is attributed to the capacitive elements in the circuit. And then we'll have the total current as a vector sum of the reactive and the real current. So here's a few definitions of what is the Hipot test basically looking for. Leakage current, which is basically an undesirable small amount of stray current which flows across the surface of an insulator or the dielectric of a capacitor. Hipot test is also looking for breakdowns, meaning which is abrupt increase in the flow of electrical current, which is basically complete failure of the dielectric material. And the Hipot test is also looking for a disruptive discharge that bridges the insulation and reducing the voltage across it practically to 0. What are some of the problems that can be detected by Hipot test? Well, excessive leakage current, weak or damaged insulation resulting in an electrical breakdown, trap of foreign particles or voids within the insulation, manufacturing defects, and some types of wiring errors, also improper spacing with respect to the ground. These are the most common problems that can be detected by a Hipot test. That is why it is required by most electrical safety standards, and it's one of the most common out of all the electrical safety tests. Here's an example of what can cause an insulation failure in the insulation. Things such as heat, scrapes, pinholes, and crimps. You can see in this example here. piece of wire is not in good shape, that could be one cause of insulation failure. Okay, so back to what we were talking about earlier, AC Hipot test. So basically, this figure that we're looking at right now is it's showing us the relationship between real, reactive, and total current. And we can see that the total current can be seen as the vector sum relationship of capacitive current and resistive current. Again, the real current is attributed to the resistive elements in the circuit, whereas the reactive current is attributed to the capacitive elements in the circuit, and hence the total current is the vector sum of the two. Some of the advantages of AC Hipot testing. Well, due to the very nature of AC current, the voltage can be applied instantly to the device being tested without needing to ramp up or setting up a ramp time. The item that's being tested doesn't have to be discharged. That's another advantage of AC Hipot testing. And due to the very nature of AC current or AC voltage, we know that it goes in positive and negative polarities. So this way, both polarities are being tested simultaneously if an AC voltage or current is being applied to a device. So both polarities are tested simultaneously. Some of the disadvantages of AC testing. Well, it measures total current, which is basically the sum of the reactive and resistive elements, and it requires a larger Hipot to test capacitive loads. Means basically a 500 VA tester or a Hipot tester, which can output a high current. Some of the advantages of DC testing. Well, one big advantage of DC testing is that real current is seen, and it utilizes a smaller Hipot for capacitive loads, which means, of course, it's going to be use less current, and hence it'll be safe for the user compared to AC Hipot, which requires a larger Hipot. Some of the disadvantages of DC Hipot testing are that due to the very nature of DC voltage and DC current, we need to ramp the voltage up, set a ramp up time in our testers. We also need to discharge the item that's being tested, and because we know essentially we're creating a capacitor, so the device under test can get charged pretty much to the same potential as the voltage being applied to it. So discharging is necessary when using DC potential for Hipot testing. Another disadvantage of DC testing is that it only stresses the insulation in one polarity. Again, that's also due to the nature of DC. It only can be in one polarity, positive or negative, not simultaneously. It is also not always accepted by agencies, and it is an inconsistent multiplier for equivalent tests. Okay, so back to the main topic of today's webinar. Once again, I would like to remind you all that don't hesitate to use our Q&A facility for any questions that you may have for on today's material, basically. And if you're having any technical issues, please contact Jim Kennedy for technical support on this webinar. Okay. So 500 VA testing. Well, 500 VA testing refers only to AC testing. AC Hipot testing. We know that manufacturers of electronic equipment are required to test their products prior to being released in the market in order to ensure that the device will not pose a shock hazard to the user. The construction and safety tests necessary for compliance as per standard agencies such as UL, IEC, or EN, they generally include a dielectric withstand or a high potential, also known as Hipot test. So Hipot test is required by almost all electrical safety standard agencies. Now we know that this is a high voltage test that stresses the insulation of an electronic device in order to test its integrity. Well, many of these standards call for a Hipot instrument capable of a 500 VA output, meaning that the Hipot VA rating is basically a measurement of the output power calculated by multiplying the maximum voltage by the maximum current output of an instrument. So basically, for example, a 5000 VAC unit with 100 milliamp trip current is essentially a 500 VA tester. So why do we need a 500 VA Hipot? Well, two main reasons are it is called out by its standard agencies such as UL, IEC, and secondly, the device that's being tested, if it has a large capacitive load, in this case, you need extra leakage current to run the test. For example, say a long spool of cable could be very highly capacitive, and in order to compensate for that, a 500 VA tester is needed to test a device that is highly capacitive in nature. Basically, the 500 VA output requirement was likely stipulated to ensure that the product would be tested at the proper voltage despite any unfavorable line or load conditions. What that means is basically heavy loading or line voltage fluctuations can greatly affect the output of an unregulated Hipot instrument. And most modern Hipot instruments have a regulated Hipot output. However, many of the standard requirements have not changed over the years to reflect the shift in technology. So there are also products which are highly capacitive and require a Hipot instrument that can output high current values. The table that we're looking at right now is showing us the basically how different agencies and different standards are calling out for different products for a 500 VA test. So, what are the 500 VA requirements? Let's look at an example real quick. This example shows in the table below where IR is the current required, which is the trip current, and the IS is the short circuit current. So the test voltage here can be seen on the left side. For the first reading, IS is 200 and IR is 100, and the test voltage is basically greater than less than 4,000, and basically these two numbers are common across a variety of standards. Standards for other products may not necessarily require a 500 VA Hipot unit. However, due to the nature of the product itself, a greater milliamp leakage current trip capability is necessary to properly test products. For example, large motors and long spools of cable tend to represent highly capacitive loads when the Hipot is when they undergo a Hipot test. As a result, a Hipot with a higher minimum trip current is necessary to receive leakage current readings. So why 500 VA? Older Hipot units did not have a good output regulation. If there was a more highly capacitive load, the Hipot voltage could drop below the set value, thus causing the test to not be run properly. And here's a quick example of a line load regulation. And if you see, right now we're looking at the unregulated Hipot output. And as you can see, it's varying. In the first picture on the left, it's varying anywhere between 800 to a little more than 1100 volts. And for a regulated Hipot output, you can see that it's consistently at 1000 volts. Okay. Now, why is 500 VA necessary? Well, in some cases, it is necessary because, as we just talked about, highly capacitive loads, they require a high leakage current output capability from the Hipot instrument. Here's an example for a 2,000-foot long spool of cable might have a 70 milliamp leakage current at 3000 volt AC. Unregulated Hipot tester should have a 500 VA output to ensure proper test voltage at the DUT. So basically 500 VA is required for highly capacitive loads that require high leakage current output capability and a regulated output voltage. Well, we know many standards are, some of them specify 500 VA testing, but there is a bit of confusion going if you read through the standards. Basically, the language needs to change a little bit to include some exclusions. Hopefully, UL and these agencies will look into this in the future. Some standards compensate by adding an exclusion, however, such as if voltage is regulated at the output, 500 VA unit is not required. For example, from UL 1730 for solar panels, it's making it very clear that 500 VA is not required in this case. However, not all standards, UL standards or other standards, call out or make it very clear to the user whether 500 VA is required or not. This is the proper approach to basically modifying old standard language to new technology. Most Hipot testers on the market currently have a regulated output. So the bottom line is that 500 VA testers are more dangerous to the operator due to the higher milliamp output capability. If we don't absolutely need a 500 VA tester, it is a much smarter thing to get a tester with a lower rated output, because again, safety is a priority, and we all know that 500 VA testers have their own safety concerns. They're very high current and high voltage. Once again, I would like to remind you guys to please use our Q&A facility for any questions that you may have. And I think we're pretty much done here with the meat of the material that we were going to cover, but just to conclude, we know that recent technology trends for Hipot testing equipment are shifting towards Hipot units with a regulated output. However, many standards still require a 500 VA output for high voltage equipment. This is where we bring in our 500 VA units to cover this requirement. Specific applications may also affect a manufacturer's choice in a Hipot instrument, as their product may be highly capacitive. So as a result, there's still a strong need in the market for a Hipot with 500 VA output capability. The associated research is able to meet these Hipot testing requirements by offering various Hipot testers with the 500 VA capability. So I would encourage you all to visit our website, Associated Research website, and browse around and see, take a look at our specs on some of the 500 VA testers. One example was the one that we showed in the video. That's a Hipot 500 VA Hipot tester. And having said that, I think we're done with today's presentation. Once again, I would like to thank you all for joining us today for this very important webinar on 500 VA testing, and thank you for your patience. We'll see you next time, and please feel free to, again, use our Q&A facility for any questions regarding the material, or if you would like to get a copy of the presentation, contact Jim Kenzie. And we're going to leave the window open right now for any questions. Thank you again.
Excuse me. So Ed, could you expand a little bit on the safety concerns in using a 500 VA rated Hipot, in a production line?
Sure. Well, we all know that 500 VA tester is a very high current tester, and it comes with its own safety concerns. And in a production or a manufacturing environment, it is very important to take extra precautions about when using a 500 VA tester. Some of the most important safety measures to remember are that the operators who are using the 500 VA tester must be well trained, well aware of all the possible shock hazards and safety concerns. They should be well trained. The test area should be a very safe test station with taking all the safety precautions, such as if the device if it's a device that can fit inside a safety enclosure, we would highly recommend using an enclosure. If the device being tested is relatively larger, we would recommend to put some safety and warning tapes around the area so that everyone in the facility is aware that high current, high potential testing is going on in this area. And at the same time, basically everyone in the facility should be aware of the safety concerns, and the operators should be very well trained and should know exactly what safety concerns may be possible here.
Can you expand just a little bit more, also talking about the GFI circuit? What does that do in a 500 VA tester to help, protect the operator, this kind of stuff?
Sure. The GFI circuit in the testers, basically it requires the sensitive measurement circuits in order to function correctly. Uh, uh, Basically, the GFI circuit automatically detects if the device under test is isolated from ground, and it also prevents the operator from being shocked in case of an accidental contact with the device under test during testing. We basically recommend that the test operator always isolate the device under test from the ground, so the smart GFI circuit is enabled, and it provides the highest level of protection against any kind of injury.
Okay, we have a question showing, says, what happened when the tester shows GFI in the display and the operator does not touch the voltage in the tester? What could be actually tripping off the GFI? Syed, did you hear the question?
Dwayne, I think we got some technical difficulties with Syed. Why don't you go ahead and answer that question for us, and then we can close up shop.
Okay, sorry about that. Okay, the question, we have a couple questions that come up here. The one is asking us to put up the slide showing the standards that require the 500 VA. If Syed could go through and do that, I don't have control of the panel. The other question that came up was what happens when the tester actually shows a GFI on the display and the operator actually does not contact voltage on the tester. The GFI circuit basically acts where it is actually monitoring any leakage that is not flowing back to the return and actually coming back through ground. It's like your standard household GFI in your bathroom or this kind of stuff, but it's set for a much lower value. many times if you are testing something that is much larger, it is much more capacitive, you may have a additional leakage path going to ground that exceeds the 500 microamp trip point on the GFI setting. If that happens, the display on the instrument will show a GFI failure and trip off the Hipot tester. It really doesn't know the difference whether it's an operator or if it's a leakage path somewhere else going to ground rather than to the return that would actually trip off the GFI detector in the instrument itself. So what can you do about that? In that particular case, if you have a nuisance tripping of the GFI, then you may have to go through and disable the smart GFI circuit in the instrument by either shutting it off or tying the enclosure of the product back to earth ground, where the return is grounded. This would automatically disable the GFI circuit also. So in that particular case, the that would be what would be required to go through it and keep the GFI from tripping off. I'm going to try to get back to the slide that actually shows the standards that actually require 500 VA. So many of the standards called out, for 500 VA, the 500 VA rating on a Hipot test many times is called off as a type test and not necessarily as a routine production line test. Depending upon the standard, you may have some language in there that allows you to not use a tester that has a 500 VA rated output. Underwriters Laboratory does that in quite a few of their standards. They may require a 500 VA rated Hipot as a type test, but in the production line, because of the safety concerns in having less skilled operators involved in going through and doing the testing, they will allow you to use a tester that has, where they're actually monitoring the voltage directly in the output of the instrument. So you can actually see what is the terminal voltage actually being applied, to the tester itself. Today in the testers, it's much easier from the standpoint that with the digital metering, whenever you initiate a test, the terminal voltage actually is displayed on the instrument much quicker than what it was with the older testers that had analog meters. Typical response time on an analog meter was anywhere from 2 to 3 seconds. And if you're only doing a 1 second Hipot test, the meter never would stabilize in on a reading to actually allow you to identify whether the proper voltage was actually being applied to the product or not. So this was a problem, in doing that testing, in a production line. So with testers today having a regulated input and a regulated output, where they're not susceptible to varying load conditions, or they're not susceptible to varying line voltage fluctuations, they would actually maintain the output voltage at the proper setting, during the, the testing operation and stuff. Okay. Are there any other questions? Hope we've done our best to go through and and answer those questions for you. We'll leave it open here for a couple more, maybe another minute or so here, and see if we have any other questions that come across. Again, I would like to recap. This webinar has been recorded, and it will be available on our website. You can go on and pull up any of our webinars in the archive section of our website at any time, and this would allow you to go through and use these as training tools for your other people within your company and stuff also. If you would like a copy of this presentation, please drop Jim Kennedy an email, and I think he just put that on the chat line where you can be able to get that presentation and stuff. With that, I think we're going to go ahead and close this. I thank you for attending. I apologize for our technical difficulties and stuff here. And if you, please visit us, on our next webinar. And, we will, if you ever have any questions, please don't hesitate. Give us a call, shoot us an email. My contact information is on the website. You can also just send any email at info@asresearch.com, and it will get routed to one of us so we can go through and answer your questions and stuff for you. Thank you very much. You have a great day.